Hello everyone, welcome to our presentation. I'm Feng Zhao from China University of Mining and Technology, and the topic of our poster is the impact of SAR image resolution in amplitude dispersion-based polarimetric persistent scatter interferometry. There are four parts of our presentation. PoPSI techniques improve the phase quality of SAR pixels by searching for their optimal scattering response for PSI applications. The more the scattering mechanism within a resolution cell, the more difficult to find the optimal response. As the resolution worsens, SAR pixels are more likely to contain more diverse scattering mechanisms. Thus, it can be anticipated that pixels resolution may have significant influence on the performance of PoPSI optimizations. However, this has not been evaluated in previous literature. The dataset we used is 30 quadrupole readset 2 images over Barcelona. Additional datasets with coarser resolutions are generated from this arranged set of images by the downsampling in the spectral domain, as this figure shows. The ground deformation retrieved from the HH channel and the optimized quadrupole data with three different spatial resolutions are shown on this figure. Despite the differences in the final PS density, the ground deformation patterns are in good agreement with each other. This table lists the number of valid PS in the estimated ground deformation results with all the datasets. The highest density of PS are obtained with high-resolution optimized quadrupole data. However, the highest improvements in percentage relative to the HH channel are achieved with the lowest data. We selected a pixel for the time series deformation analysis, and the results are shown on this figure. The HH and quadrupole data obtains very similar time series deformations, but the results are different when comparing the 5 meter and 20 meter results. This is because different targets observed inside the resolution cell when resolution worsens. For the 10 meter resolution case, time series deformations from the quadrupole and HH data are different. The 10 meter HH data tend to observe deformations of similar targets as the 20 meter data. However, through the optimization, the 10 meter quadrupole data are able to obtain the dominant scattering mechanism that close to the 5 meter data. Based on this study, we have the following conclusions. Firstly, the DA-based polarimetric optimizations improve the density of valid PS pixels with respect to the Singapore reference channel for any input pulsar dataset. Secondly, the improvement in density of valid PS is more significant in percentage with respect to the HH channel as the image resolution worsens. Finally, it's worth processing the two channels of the Sentinel-1 data by applying the polarimetric optimization with DA for PSI applications, since it will provide more density of PS than just using the VV channel. More details can be found by reading our recently published paper and the TGAS. Thanks for your attention.